Okay, I think we're all here. I don't know whether this is going to record it or not. So, my name is James Cass. I have been giving this lecture for the last 12 years or so, and I think this is the right course. It's space psychology, space medicine, right? Okay, good. We're going to go into the psychological issues of long-duration space missions. And this lecture, which is 2 hours, which I will try to compress to 2 hours, has 6 parts. I'll first introduce you, well, I'll introduce you to myself also, but introduce you to the problems and consequences. We will go into countermeasures and research. Very briefly, look at some journals from the ISS. That'll be the first hour. And then the second hour, we're going to look at some tools regarding groups and group dynamics, such as leadership, which is very important in a team, and even more important is handling conflict. And then the very future, Mars, which is not that far away, and I want to reserve the last 15 minutes for that. So if at 1:45 I don't get to that point, interrupt me and tell me, because it's very interesting. So I'll maybe, yes, I'm on this one. Okay. So I will tell you a little bit about myself. Now, I just want to say regarding posting of lectures, some of you are taking a lot of copious notes. You can do so, but you will get the PowerPoint afterwards. So that's not a problem. It's going to be posted for you, and you can download the PDF of all the PowerPoint presentation. So you will have everything that's written on there. However, any extra notes that you think about, of course, write down. But don't bother copying that, what you see up there, because you'll get it anyway. So you can relax and enjoy yourself without having to take too many notes. I'm trying to record this at the same time, but I'm not sure if I'm going to be successful. Somebody has placed here a dictaphone, and maybe afterwards he can also put this on the internet as well, and you can have that recording as well. Just to tell you about myself, some people have asked me whether I'm a psychologist. By training, I'm not a psychologist. I'm actually a physicist. And in case you are wondering what you are studying about and whether you will always do this all your lives, well, you might not. I started out in nuclear physics. I went on to neurophysiology, which took me into the neurophysiology and weightlessness in spaceflight. I went into medical technology, behavioral and operational psychology, where I became an associate professor, and did some telemedicine and e-health. Then I branched out very broadly into looking at integrated space applications and using all of these space infrastructure for humans, for applications here on Earth, knowledge management, data privacy, lessons learned, and lastly, Mars 1. I'll tell you all about Mars 1, where I'm an advisor, and we're hoping to send people to Mars pretty soon. Well, we'll see. This is some selected reading. It's a bit out of date. I don't even know. There must be a newer edition of Nick Canis and Dietrich Manse's book. It's more of a textbook on space psychology. So I believe they must have it here available. Kevin Fong should make it available for you in case you really want to look into deep analysis of space psychology. It gives you a lot of good references. There must be a newer edition now. An even older book, Patricia Santi, Choosing the Right Stuff. She writes about all the problems regarding choosing the right stuff in spaceflight. It's a very candid book. I think she lost her job as a result of it. She used to work for NASA. And Dragonfly is a very interesting book. It's a challenging book. It tells about the Americans working on the Mir station in preparation for the ISS. And there were a lot of problems, psychological, cultural, etc. I liked the book particularly because I knew many of the characters in the book. It talks about the problems in Star City and the training and everything else before the mission. And I was there actually when it happened, and I knew many of the people involved. So I know a lot of the The journalist was very good, and he really, the writer is very good, and he really has done a good job of capturing it, because the little information I knew about was very accurately portrayed in this book. This is not me, this is somebody else, actually related to me. There is a whole series of books by Ray Cass on group dynamics, which are very useful in case you are interested in going into group dynamics in general, not necessarily with space flight, but the behavior of groups. Then you can look on the internet and see there is a whole series of books on it, and they're based on a lot of practical work, not just theory. It's really practical, down to earth. Then, of course, there is the Mars 500 simulation where people were shut up. I'll give you a more updated reference list on the internet, on the university internet. And, of course, there's the Sphinx mission, there is the Arctic expeditions, and lastly, there is the most recent Mars 1 mission. So, now for the first part 1. And we'll have to go through this fairly quickly. Don't worry about it. You will find it all, you can read all about it. I'm going through it a bit quickly so that I will make sure we get to the interesting parts and allow you more time to talk, to ask questions. Don't hesitate to raise your hand and interrupt me, because I will just keep talking, and I can fill the whole time by talking. So if you don't interrupt me, I'll just keep talking all the time. The domain, where does it apply? Of course, we are talking about long-duration human spaceflight, so it's mainly, right now, the poor astronauts are rotating round and round and round and round the Earth for whatever purpose. I think it gets boring after a few thousand orbits, and this has been going on for years. I was involved in the early space flights where we started doing experiments. Back in the early 80s, well, actually in the late 70s, obviously we had the Russians with Soyuz and the Americans with Skylab. This was the pioneering days, but they were technological missions, very interesting. And then we had the early Spacelab missions, where we started doing the first experiments. International experiments. There were about 100 experiments on the first Spacelab space shuttle mission back in 1983, which I was involved in, and there were on board at least one European astronaut on Spacelab 1 and on Spacelab D1. 2 years later, there were 2 or 3 of them. We are also interested in the application is the moon, but more interesting is Mars and the planets, because these are really far away, and if you're going to go there, you may not come back. You may settle there. Do you really want to do that? I don't. But anyway, some people do. Now, you have also analog domains, which we should talk about. There are extreme environments, exploration, Arctic expeditions, etc., which have similar type of problems. So where does this apply? It applies there as well. But probably, how many of you think you're going to go into space one day? Nobody. Okay. Oh, one. Very good. So most of you are not going to go into space. So you say, well, what am I doing all this for? Well, this course in space psychology of groups will apply in your everyday life. You are always going to be working with groups. You won't be working in space, but a lot of the problems I will be talking about regarding long-duration group dynamics are entirely applicable on the Earth. It's just the problems are slightly exacerbated in space, but the problems are very similar. And you can apply them in your everyday life, in your work. How many of you are going to be medical doctors or nurses? Ah, a number. That's very good, because I do believe this is very important for your profession, because you are always going to be working with people, not just the patients who are unconscious on the surgery table, but in your maybe patients, if you're a GP or you're talking to the patients, and the nurses working with you, the other doctors, the hospital staff, the administration. They are all teams within teams. And if you are going to be working in a way to be safe and to take care of the people you are supposed to, and train those you are supposed to train, then the behavior of the group and how the group works together is extremely important. So it's applicable everywhere. So it's not just for fun. This you will learn something about real life, and I hope many of you will already know some of the main things. Now, before we go into the psychology aspect, I just want to go into some aspects of what we are talking about when we talk about space flight. Do you know what the radius of the Earth is? Any volunteer? None. Okay. You guessed right, 10,000 kilometers, about. At least Napoleon thought it was 10,000 kilometers because he based the measurement of the kilometer on being 1/10,000th of the Earth's radius. It's not, but it's approximate. Do you know how high the ISS laboratory and all these orbiting astronauts are above the Earth? Have an idea. Let's get some guess. How many to the nearest 100 kilometers? I'm using kilometers and not miles. Sorry about that. How much? 500. Oh, excellent. About that. 350 to 500. That's about right. I'm just giving round numbers. Yeah? So when I put 400 here, 500 is also exactly the same. Because we're just talking of the ballpark figures. We're just trying to understand roughly. This is not a lecture in astronomy. We're just looking at psychology. Yeah? And we only want to know roughly what's going on, what our boundary conditions are. Because the satellites you're communicating with, these geostationary, they're communicating like the GPS navigation signals, etc. The old GPS ones, the new ones are slightly lower orbits. How high are these stationary satellites above the Earth? Does anybody have an idea? No? Those are more the low orbit satellites, yes. And the next GPS satellites will be some of them are low orbit, but many of them will be the 15 or 20,000, and the geostationary are 40,000. Quite high. When you think of how low the ISS orbit is. Yeah? So the ISS orbit is not very high. It's only from here, not even from here to Paris, halfway to here, from here to Paris. How far away is the moon? Because we've been there. You guessed right, 400,000. Much further away. So we're talking of long distances. This was when Apollo 13 had their problems. They realized they will not be able to be rescued very easily. But actually, even 400 kilometers up there, when the space shuttle is up there, to send another space shuttle or a Soyuz rocket takes weeks, if not months, to prepare. So when the crew of the STS-107 mission, when they realized their shuttle was damaged, they realized they may not be able to come back down to Earth because one couldn't rescue them. And they didn't come back down to Earth. The STS-107 mission, they all died on the way down. This is a most tragic mission. We can talk about the psychology of it later. I was involved in that mission. I knew the crew very well, so it was a very sad occurrence. After that, I started going to other areas of spaceflight. I got a bit discouraged with human spaceflight. The moon gravity, it's less than the Earth. Any guesses? What fraction of the Earth's gravity? No guess. You're right, it's about a third. So it's much lighter. You see these films of the people jumping up and down there. Mars distance from the Earth. Now this is getting interesting because this is really far away. And of course, if you read science fiction, we're going to the stars. But that's the nearest next planet. Any ideas? Probably not. I won't wait. 450 to 400 million kilometers. So a round trip to Mars, if you're going to go to the nearest point, Mars has an orbit which is huge, and partly it's very close, only 50 million kilometers away. And that's where you get to it. And if you want to go there and come back while it's close to the Earth, because if it's far away, it's going to take you years to do it, you would have to go and come fairly quickly, and it would take you about 500 days with today's technology. So a long time. If you decide to stay on it for a while, then you'd have to wait for an orbit, and that takes 2 years for it to come back again. So it'll take much longer. So it's quite far. The orbit is 2 years. Mars' gravity is similar to the Moon's, slightly higher. And Jupiter, which is another interesting planet, quite far away, Alpha Centauri, distance from the Earth. This is the nearest star. So if you're talking about science fiction going to other stars, this is the closest one. It's very, 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 very close. And it's 4.3 light years. What's a light year? Well, it's the time light, the distance light travels in a year. 10 million kilometers, roughly. Huge distances. So if anybody tells you, if you see these science fiction saying we're going to get into this, into our rocket and fly off to another star and get there in a few days' time, it's all rubbish. It will take you a few million years to get there. So you won't get there. So unless we have some form of instant teleportation, but at the speed of light, which nobody can travel, and I can tell you because if you get anywhere close to the speed of light, your mass will go up infinitely, and you'll need infinite energy to accelerate. So it's not possible. And even if you did achieve that, it would take you the 4 years to get there, but you wouldn't. So it would probably take you more like 4 million years to get there. So take science fiction with a grain of salt. A typical Mars mission will take 500 days for a short turnaround, 1,000 days for a longer turnaround. You're talking of long periods of time. You're talking of time delays. You can't hold a conversation. You say hello, and about half an hour later, you get the answer saying hello. So it's not very nice. Setting an SMS is going to be easier, because then you can wait a couple of hours to get your answer. So holding a two-way, even chat will be a bit difficult. So if you're going to do any telemedicine, if you're going to perform an operation and get some advice, I think you better get all the advice at one point and then turn your communication off and do what you have to do, because you won't be able to interact. So we are talking about people going to a place where they are going to be totally dependent on their own skills, limited source, food, etc., and being away for several years. So it's going to be a really psychological stress. So we go into the next one.